What is meant by an atomic orbital? Atomic orbital is a mathematical function that describes the wave-like behavior of either one electron or a pair of electrons in an atom. This function can be used to calculate the probability of finding any electron of an atom in any specific region around the atom's nucleus. Each orbital in an atom is characterized by a unique set of values of the three quantum numbers n and m, which respectively correspond to the electron's energy, angular momentum, and an angular momentum vector component, the magnetic quantum number. This is s orbital. We can say that s orbitals are spherically symmetric, having the probability of finding the electron at a given distance equal in all the directions. There can be 2 electrons in one orbital maximum. The s sublevel has just one orbital, so can contain 2 electrons maximum. A p orbital has the approximate shape of a pair of lobes on opposite sides of the nucleus, or a somewhat dumbbell shape. An electron in a p orbital has equal probability of being in either half. The p subshell can hold a maximum of 6 electrons, as there are 3 orbitals within the subshell. The 3 p orbitals are at right angles to each other, they are px, pi, and pz. This is d orbital. They have an even more complex angular distribution than the p orbitals. For most of them it is a clover leaf distribution, something like 2 dumbbells in a plane. There are 5 different d orbitals that are nearly identical: dxy, dyz, dxz, dx2y2, and dz2. These different orbitals essentially have different orientations. In the case of dxy, dyz, dxz, and dx2y2, they are planar angular nodes, easily seen as the axes which bisect the lobes of the orbitals. In dz2 they are conical angular nodes which divide the donut part of the orbital with the upper and lower lobes. Every orbital can hold up to 2 electrons maximum. There are 5 d orbitals gives maximum 10 electrons. F orbitals are very complex and difficult to describe with words. It is oriented in 7 different ways, and each orientation can hold 2 electrons. Therefore F orbitals together have 7 degenerates and can hold maximum 14 electrons.